Just coming in okay? You guys hearing me okay? All right. Hello, mic check, 1, 2. Cool? No? On my t-shirt, all right. All right, just hold it. Mic check, 1, 2. All right. Well, thanks everybody. Hope you had a good break. My name is Puey. I'm CEO and co-founder of Airbitz. And a lot of people know Airbitz as a mobile wallet for Bitcoin, but today what I'm going to talk to you about is single sign-on and what it has done to make our life easier from the viewpoint of authentication, but how we can apply it to the blockchain ecosystem and what we're doing specifically to enable this. So before we talk about single sign-on, let's talk about kind of the blockchain itself. And this is pretty common knowledge to everybody in this room. This deck is probably more than you really need to know, but obviously a blockchain does require private keys. There's something unique about it. It is a database. It's a decentralized database, but the only way to authenticate with it is through private key cryptography and digital signatures. And so this is a unique piece that is kind of new to our world when we talk about using applications. Normally, we're used to using applications using normal authentication mechanisms, but now we have to secure private keys. But what does private key security look like for the past few years of using Bitcoin? It's looked like this screenshot, which is requiring someone to save, I think it was a 15, 16-digit random seed or key and a document that you have to save off your phone and store both of them. And you can't lose any of them. You can't change this random password, lose it, and you effectively lose funds. Another example, which is really familiar in the space, the 12 to 24 word seed of random words that we ask a user to save, write down on a piece of paper on these instructions, put it in a safe, all of which are not terribly hard, but they're incredibly unfamiliar. And that's one of the critical challenges of the crypto space, is that the... Sure. Cool. All right. So not incredibly challenging, but definitely unfamiliar for the crypto space. And this is what we're trying to do to get people to adopt crypto technology, Bitcoin, other blockchain applications. This to me is the cream of the crop. This is out of an Ethereum application, actually one of our partners, Augur, which in the process of creating an account in the app, you enter a password, and then you get this giant jumble of stuff at the bottom. This is actually your username. And then they have you take that jumble and save it somewhere and not ever forget the password, which not only can you not forget, you also cannot change. This is effectively the user experience that we're building for the blockchain application ecosystem, which we intend or hope is going to replace a lot of the centralized applications that we're using today. So a huge challenge with respect to adoption. So what is the solution? Well, we could take keys and just put them on a central server. That's pretty convenient. You just log in with a kind of conventional password, forget your password, they send you an email. But that model definitely has its weaknesses. We can attack central servers, attack the people that work with them, the network that connects to them, and trusting third-party storage providers has proven that it really doesn't work, and we see a lot of the issues with that. Hacks all over the place, especially in the crypto space, as well as outside of the crypto space. A major retailer in the US, Home Depot, got hacked for about 56 million credit cards. And really the challenge is that there's just too much incentive to hack these centralized services. You've put a tremendous amount of value in one place and give people a target. So I liken this to the castle model, where we build these huge castles, and yes, they've got really, really thick walls. They've got these moats, these water moats around them, but you put it at the top of the hill, and so therefore everybody knows where it is, and everybody knows that that's where the value of potentially the whole kingdom is. And even though you've got the great moat, you do have to lower the drawbridge at some point in time. So even though you want to keep the right people out, you've got to let the wrong people, you'll occasionally let the wrong people in. And then there goes your attack vector. And so what we fundamentally believe is that in the crypto space, we've built this model of edge security. Not just Airbitz, but pretty much every wallet in the space is targeting the concept of securing data at the edges. So securing the data on individuals' users' devices, on their phones, on their tablets, with hardware wallets. And doing that before any data gets sent onto the network, whether it be encrypted data or signed data for the sake of crypto transactions. So the beauty of the security model is that not only does it make it much harder to attack the entire system, it lowers the reward for even one successful attack because you'd only get the value that's in one device. So this really inverts the model of security and inverts the model of the kind of game theory. So security not just by technology, but security by game theory and incentive. which we think is a fundamental change in what we've been doing for the past few years. So what's the challenge of this security model is that the tools to implement the security model have been very challenging for users. So things like encryption and backup, those have been available to us. We've had the tools to use them, but for the most part, people don't do it unless it's done for them, such as when you put your data onto a central server, they back it up for you. So tools, backup, synchronization, revision control, password recovery is very unforgiving when you use encrypted tools. Two-factor authentication to get to a location where your data is stored, most people don't utilize. So the average user doesn't use a lot of this stuff. And that's effectively what we come in and try to help with. We take a lot of these tools that are available to the general public. This is technology that we've had for 10, 20 years, and make it not only accessible, but nearly invisible on the platform, where you get it without even knowing it. So data on our platform is fully encrypted, client-side with users' credentials, automatically backed up. We implement synchronization, so you can access the data from multiple places, as well as revision control, rollback. And one of the big bullet points, which is why I have in bold, is actually a mechanism to do password recovery in a pretty familiar way, which is, for the most part, non-existent in the cryptography space and actually encrypted data. And all of that is familiar enough with just regular login credentials that people would expect when they use a regular mobile app or a website. And then to take it one extra step further, which is what we're talking about today, is single sign-on. The concept that we can actually use the same set of credentials and log into or authenticate with many different blockchain apps. And so what we've built effectively is the first single sign-on that can actually work for encrypted data. Because we've used single sign-on before, we've used it for with Google and Facebook, but as you'll see, that can't work for blockchain applications. So what does it actually look like to experience single sign-on with Airbitz, which is what we call Edge Login? Well, you have what looks like a normal account creation screen and a barcode, which a user can go and enter just the regular credentials to create an account, which actually creates an encrypted repository, which is backed up and synchronized between the different browsers or websites. Or they can take a mobile app, which is the Airbitz wallet, simply scan a barcode, and have an encrypted repository created that's linked to their master Airbitz account. And that's automatically backed up as well. So I'll show a quick kind of demo, not a live one, because I don't trust internet connections in places like this. But so a quick demo. On the left here is a screenshot of Augur, which is our launch partner for Edge Login and single sign-on. On the right is a picture of our mobile wallet. And so, let's see, this is starting. So, regular site, your user is not logged in. They can simply click on the usual sign up and login button. And they'll get a little sign up with Airbitz button. And click on that, and you'll see the normal login screen. And so they can, if they're just a brand new user, don't have an Airbitz account, just enter a conventional username and password right into the screen. The UI is actually all done in the Airbitz SDK, so you don't have to build that as a blockchain application developer. Enter a conventional password, PIN, and then they just click register. And so this takes about 10, 12 seconds, because what it's actually doing at this point is it is creating a repository of data, it's encrypting that data, and it's backing it up onto multiple peer-to-peer servers, making sure that it's secure before it allows the application to now store data into that repository. And so once that's done, user's done, account is created, it's entirely backed up. Nothing left for the user to do unless they want to set up password recovery. So this is the password recovery process that you'll see if a user uses to do it, which is simple personal information questions. They choose two, answer the questions. And a lot of people have seen this. This process is not too unfamiliar from registering with a bank. One slight difference, however, is that once they've answered the questions, they're asked to send themselves an email. And this email does not come from us, it actually comes from themselves. And what they're doing is they're sending themselves a token, a unique random number that is required for them to recover their account. They get a few buttons, they can choose which email provider or a generic email application. I chose Gmail in this case, launches my email app, and then there's the email populated, ready to go. They just go ahead and simply send it off to themselves, and it has that recovery token inside as a link that they can click at a later point in time. So once they hit send, they're done. The account is both set up, it's encrypted local client side, it's backed up onto multiple servers, and they have password recovery capability that they can use in the future should they forget the password. And now the account is logged in. Private keys for Ethereum, Augur are created. There's an account name and there's a public address that the user can use. And that's it. That's the process that we've built to make it very, very familiar for a user to create an account, and then there's UI for them to change the password, PIN, change their recovery, as you might expect out of a conventional application or web app. And then if a user signs out, an encrypted version of the repository still sits in their account, and they can unlock it with just a 4-digit PIN, not having to scan a barcode again, not having to enter the full password, which is somewhat inconvenient. So a simple 4-digit PIN signs the back end to that application. So that's not necessarily single sign-on. That's trying to drive a familiar user experience to a blockchain application. But from the viewpoint of single sign-on, we can sign out of this app, and we'll kind of launch another tab here. There's the application starting up. And we'll sign in again. And instead of entering any new credentials, you take the phone that you see on the right side, and that's just logged into an Airbitz app with an account on Airbitz. And you just click the scan button. Just like you would scan a QR code for sending money, this time I'm going to scan the barcode for logging into this app. And the process of doing that will present to the user what is the application that wants to sign in, and what does it want. Effectively, this app wants an account of type Augur. The user can just hit accept to say, OK, I accept that I want this to log in. It then actually creates an encrypted repository, passes it over to the client-side application, which can unlock it, put private keys into it or other data, then encrypt those keys and have them backed up as well. And all of that is happening after that user signed in and clicked accept. And it does take a little while because it's not just authentication, it's actually encrypted data store passing between applications. And that's it. With a one barcode scan and the tap of one button, this user has now created an account with Augur that is encrypted and backed up and synchronized. If you already had an account linked to this mobile wallet, it would present that account to the client-side application. So in this case, I already had an account. As you can see, it has some testnet Ethereum, some testnet rep, and it effectively logged in with that same account that I already had linked to my wallet. That's all that this demo video had. Cool. All right. And that same account, you can, once again, log in with a PIN the second time so you don't constantly have to scan barcodes over and over again. Cool. So that's a quick little demo of what it looks like to use kind of single sign-on for blockchain apps. So what was actually happening in that video when I scanned that barcode and logged in? Because we want it to feel familiar. We want it to feel like single sign-on, but underneath the covers, so much different stuff is going on. What was really happening is that barcode was a link to a data store. In that data store was a public key that the phone can use to encrypt data and transfer data over to the client-side application. So it was putting in that repository, hey, I am an app. Here's the name of my app. Here's a link to a logo for my application. And here's the type of repository I would like, just by name. And so when the phone scans it, it sees that, presents that to the user, and then sends the encrypted account back over the channel, through that encrypted channel, after it creates that repository. The client-side application on the browser then says, OK, great, now I've got this encrypted repository and a key to put data into it. It then creates private keys for Ethereum and Augur and goes ahead and puts that key into the encrypted repository. And then it's effectively done because that repository has already been backed up and linked to the master account. How does regular single sign-on work? How many people ever use Google, Twitter, Facebook to log into various sites? I'm sure almost everyone here. I know we're all guilty. They're great services because they do make things a lot more convenient for us. But how do those single sign-on solutions actually work? Well, you've got a website here, and say it wants to allow login with Facebook. Well, it says, hey, Facebook, could you please log in a user for me? So it's OK. So Facebook then presents a user interface to the user and says, hey, Alice, please log in. Present to me your credentials. And then Alice does so. And then Facebook servers say, yeah, those look pretty good. Goes and tells the website, Alice logged in. Trust me. She really did, and it really was Alice. But there was no end-to-end encryption of any data, and you had full trust in those Facebook servers saying that Alice logged in. So in essence, it works for authentication to a central server that you're already trusting, but it's not good enough of a security model to actually secure keys in an edge-secure manner where only the end user has access to those keys. So we fundamentally think that this is kind of the shift. The nice thing about what we've built, or the edge secure model, is that you can still use it to authenticate with regular websites. You don't have to use those keys for a blockchain. You can use them on regular websites. And if you are a blockchain application, so how many people here are developers? Handful? Okay, good. I'm not going to alienate too much of the crowd by showing code, but I'll show a couple slides of code to show how simple it is to integrate Edge login into your app. This is pretty much boilerplate. One little block of code, you put in an API key, you put in the name of your application, as well as a link to your image, and a name for the type of repository, and boom, put that in your code, and that's done. Pretty boilerplate, copy, paste. And next, you make one call, open a login window, and that's really it. All of that UI that you saw, that showed a barcode, that showed username, password, that allowed it to log in with a PIN, allowed it to log in with a pass, all of that is done for you by just doing one, not really API call, but actually an SDK call. Because all this happens client-side. We can't provide an API to our servers to do it. That's effectively it. And when the user successfully logs in any of the multiple different methods, you just get this account object. And then you can do something with that account object, such as create a wallet. So one call to create a wallet, which is really an encrypted repository. A wallet really isn't a good name for it at this point. Think of it as a data store. And in there, you can put a key. And that key then gets encrypted, and it gets backed up and synchronized so the key is secured in case the user screws up. And that's effectively it. From there, you take that key and do whatever you want with it. Do crypto transactions, authenticate to other servers. In essence, that key might just be general data as well. And we're going to be exposing more API to be able to store arbitrary key value stores that are not necessarily keys for crypto, but they could just be data for other applications. One really exciting thing that we've built in this data model is not just your ability to log in and get back keys, but actually the ability to share data, encrypted repositories underneath the covers between applications. I'm not sure if you'd mentioned, many of you said that you used like Google and Facebook and Twitter to log into sites. How many of you used an app that used Google to log in, but also used Google Drive as its data store to store the actual information for the application? Probably not too many people, a few. I have for some apps. Well, you can think of our data model as that, but all client-side encrypted so that Google doesn't have access to that data, neither do we. So we're in client-side encrypted key value database that can share between applications data at the user's permission. So in the beginning of time when we launched our wallet, really all that was there was this blue box, which is the user's credentials, the green box that says Airbitz mobile app, which is our wallet, and then the red box, which are the different wallets. And each of these are different data silos, all encrypted data silos. With the expansion of us providing single sign-on, now we have different application silos, each shielded from each other, but they can actually link and share a data store such as a wallet, allowing them to share keys, share transaction metadata, or in essence, any data that the application might need to generate and secure client-side. So what can we do with the single sign-on model outside of the blockchain and the security model outside of the blockchain? This is what we're really pretty excited about, is that for people that are building apps that just adhere to a strong essence of privacy and security that may or may not access a blockchain, we can actually secure data for things like financial transactions, transactional info, healthcare records. I think there's a lot of murmur about using the blockchain to secure healthcare records, but in essence, a blockchain isn't that great for securing data because it's generally transparent, and maybe that changes with some of the stuff that the guys at Zcash are doing. But for the most part, it provides transparency, not really security of data. Well, we can secure data in these encrypted repositories, as well as using private keys to authenticate to devices and other services such as IoT devices. Authenticating with those devices using public-private key cryptography far exceeds in security than having them have separate individual credentials for all of those devices, as well as personal information, password managers, contacts, address books, things like that. Cool. And of course, what I'd mentioned, what we were for the past couple of years, 2-3 years, that people do recognize us as is just simply a mobile wallet for Bitcoin. So some people here, who had raised their hand and they said they didn't have any Bitcoin? Some people did. So whoever you are, come see me after the talk. You can download Airbitz the wallet, and I'll send you a little bit of Bitcoin so you can experience it. And for those of you that are developers, I knew. That's why I asked first. Already snapshot. Already know who raised their hand early on. But for those that want to feel what the experience is like to use the platform and provide that type of edge security for your app, you can use Airbitz to experience that. Also go to augur.airbitz.co, and you can actually see that demo live. And it's actually usable today, but with testnet coins. And so the app does use edge security for not just private keys for Bitcoin, but also transactional metadata. So it secures kind of like Quicken, QuickBooks type information, pay, category notes, in the same sense that it secures private keys, as well as all of the application settings. All of that is secured in the same way, as well as edge logging in, single sign-on to other accounts as well. Yeah. And one thing that we're doing, a lot of people that are pitching blockchain companies and saying what they're up to, they do ICOs and equity crowdfunding. We're launching, and we're in the middle of the first US equity crowdfund for Bitcoin for non-accredited investors. So we realize one of the values of the crypto space is democratizing access to financial resources, especially investing in companies. But that's been very restricted, especially for US companies, to accredited investors, the top 0.1 percentile of the wealthiest people in the world. Well, regulation is eased up, and we're taking advantage of it, and also leveraging Bitcoin so that people all around the world can invest and not have to pay wire transfer fees and a lot of the costs of international payments. And so we also want to help any other companies that are looking at fundraising and maybe don't fit that ICO model as well, the way we don't, to be able to leverage equity crowdfunding. We're doing it for our company right now, and you can find information on airbitz.co / #funding. But we're happy to talk with other companies that want to do that as well and help them with the process that we went through to launch the campaign and see where we can help them improve on it as well. And it's not an ICO, it's real equity ownership or agreement in the company. And that's it. Happy to open up to any questions. If there's any developers that want any additional information on utilizing single sign-on, edge login, you can go to github.com/airbitz. The SDK is open source, and you can just take a look at it, let us know, and give us some feedback. Happy to take questions. I saw a hand up here.
The everyday user, someone who's not versed in cryptography or cryptocurrencies, when it becomes more mainstream, how would you differentiate your offering something like 1Password or some sort of password?
Right. So effectively, Airbitz actually is a 1Password, except it's an SDK you can build into the app. So to me, 1Password is a great model. It allows me to have one really, really, really good almost not quite cryptographically secure password. You can't have one that you can remember, but having a really good password that can encrypt everything else. Now the challenge is, what about my actual data that I want secured, not just a password? So I use a LastPass application or a 1Pass type of application to put like my credit card info and my address and whatnot, but it's clunky to copy and paste that between applications. It's also not feasible for the application to store just arbitrary data that it wants in those apps. So we're building effectively the 1Pass, LastPass, KeyPass that's baked into the app and using a single sign-on experience to get between the apps and a data store that the apps can share with the user's permission. So that's effectively, hopefully that answers what you're referring to. And also a LastPass, 1Pass type of application could easily fit this model. So I invite anyone that wants to build one. It would actually be a great hackathon project over a weekend to build a basic password manager, utilize Airbitz, and we would help market it through the existing accounts that already exist on our platform. So that's one advantage too. By using the platform, you get access to a lot of the people that already use Airbitz as a wallet or already have accounts with any of our partners.
What's the similarity and the difference if you compare against something like Uport?
Uport, okay, great. A lot of people have compared us to Uport. How many people have heard of Uport from the team? Cool. It's an Ethereum project that's doing, I guess, something like single sign-on, but only for Ethereum applications. The main difference is, yes, they do have a mobile application. You scan a barcode to kind of sign on. The difference, and please, if anyone out there is more knowledgeable, correct me if I'm wrong, but this is my understanding from reading the white paper and talking to some of the guys, is that the keys only exist on the device. And so any time that the client-side application wants to sign a transaction, it requires the user to launch the app on the phone, scan a barcode, and sign the transaction every single time. So there's an inconvenience aspect to that. Second, they don't have the ability to secure any arbitrary data. It's just a key signing mechanism, and it has to be on Ethereum. So really, it only works with Ethereum apps. It's only a key signing mechanism, can't secure data, and it requires you to use the app for every single transaction that occurs inside of the app that wants to utilize Uport So hopefully that answers your question. I know there's one person that had raised their hand a while ago, so I want to get to him. Oh, with Clef. Okay, so Clef is more like a Facebook and Google and Twitter sign-on. But instead of signing into Facebook with using a password, you're effectively signing into Clef with a barcode scan. So it feels the same, but it's basically public-private key signature to Clef's servers. And then Clef servers go and say to the website, hey, Paul logged in, trust me. Now, I believe that they do have a multi-signature aspect signature service that hasn't been as widely deployed because it is a bit harder to implement. But their first X tens of thousands of websites or 100,000 websites that are implementing Clef are effectively doing the Facebook, Google type of system. And there's no data security there either. So you're 100% trusting the Clef servers. You're just experiencing the same barcode scan that we're presenting. But you're right, that it's a similar experience. Yeah.
Is your product offering open source? And if so, would it work with trusted hardware like the Trezor wallet or Ledger Blue, anything of that sort?
It is open source, and people are welcome to add that. The only challenge is that with hardware wallets, the concept of what we're securing and how we're securing it is by client-side encryption with credentials and then backup, which you're not going to be able to get software backup of a hardware wallet. So I think a hardware wallet fundamentally is great, especially if you're securing many people's funds, if you're doing it kind of at an enterprise level. From an end-user level that you're trying to use a client-side application, potentially multiple. If we fundamentally think that the blockchain space is going to replace several type of applications we're going to be using, e-commerce, insurance, ride-sharing, whatnot, then I think using a hardware wallet starts to become a little cumbersome across the different application space. Correct, yes.
One set of passwords for your mobile, which uses your social login, and then all your 2FA stuff could be on the main account.
Possible. It is open source. People are welcome to contribute. I'd love to hear how that kind of works together, because we've thought about that as well. Like, how does it work together when one model is kind of fundamentally different than the other? In a way, one thing that can be done is some hardware can be used as a second recovery tool, as a key holder for a recovery key in case they forget their passwords. That's one thing that could be used, because we're not doing signatures per se. Our platform is data security, not so much signatures. And a lot of those hardware devices are primarily for signatures. But definitely want to talk about it. Maybe that's something we talk about over a beer and see how we can incorporate that as well. I am not, so I'm not going to be able to have an opinion, but definitely come educate me afterwards, and I'd love to try to express an opinion once you do. Yeah. Cool. Any other questions? There's a few. Yes?
I just have to clap for that.
Oh, okay. Mm-hmm.
What extent does that compromise stay contained to whatever data is being worked on by that particular instance?
Mm-hmm.
To what extent that actually spreads across their devices?
So we go back to this screen right here. So when a user uses the Edge login system, they have their credentials entered into the phone. So once the credentials are entered into a device, it has full access across the different apps to be able to share that access. So we fundamentally think that your phone is actually your most secure device for the average user, for what the average user would do. If you're a crypto enthusiast and that have great secure Linux boxes, that you're an exception. But for the average user, phones are most secure. When they log into a site, like say they logged into Augur, this app only has access to the green box and the red box and not anything else. So it doesn't have the link. It doesn't get the link to those data stores. It doesn't get the key to decrypt the other data stores. So they are sandboxed cryptographically. But as soon as you do share, once you share one of these repositories, then yes, it has access to that if that device gets compromised. But this is a way of segmenting access. So one could have, for example, an Ethereum wallet that is linked to one Ethereum app, but not to but linked to their mobile app, but not to their Ethereum client-side JavaScript app that maybe they don't trust as much, and actually have funds that are maybe smaller on the less secure device and hold larger funds on your more secure device. So there is definitely sandboxing across these lines. So these lines show exactly the access. If that line isn't there, then there is no access, cryptographically.